Alright, so in this video, we're gonna learn to solve trigonometric equations. And there are a lot of questions here, and unfortunately, I can't go through all of them because the video would be too long. So I'm gonna go through the highlighted ones, and hopefully we get to cover all the examples or all the types of questions you're gonna face from this topic. So when we solve trigonometric equations, first of all, you need to watch out for the domain restrictions. So that is going to be number one. Number two, you need to remember your quadrants. So if you remember ASTG, all students take coffee, all students, add sugar to coffee or something. All trig functions are positive in the first quadrant. Sine and cosecant are positive in the second quadrant. Tan and cotangent are positive in the third quadrant. Cos and secant are positive in the fourth quadrant. All right, so that is what you need to remember, your quadrants. And usually there are two ways to do this. We first find the acute angle. We can use acute angles plus symmetry to solve these questions. And we're going to get to what it means in a minute. Or we can just use symmetry, and there are a few formulae that you can use to directly get your answer. That is also fine. All right. So basically, rather than just me saying these things, let's just do some questions, and hopefully you'll sort of get the big picture on how to solve these questions. All right. So we're only going to go through the ones that I have highlighted because it's going to be a very, very long video if you go through everything. So, all right. So first question is, tan x is equal to 1.5. And we're going to use decimals a lot for this as well. So I'm going to pause for a while and be back with my calculator. And yeah, all right. So the first question, so we're going to do the highlighted one. So the first question is tan x is equal to 1.5. Now, if you remember the graph of tan x, and I'm going to only draw the graph of all the functions once, but tan x looks something like this. Right? And basically, this is 90, right? This is 90 degrees, or pi by 2 radians, and this is negative 90, or negative pi by 2 radians. All right, so if the output, which is positive here, if it's positive here, then your angle is an acute angle, and it's going to be positive. It's going to be less than 90, right? So your angle is going to be somewhere here. And this is also keeping in mind that when you take for inverse tan, the domain restriction, if you want to take the inverse, the domain restriction is between negative pi by 2 to pi by 2. And another thing you need to remember, so for tan inverse, right? And another thing to remember is that the period for tan is pi. So tan repeats for every pi. The value repeats for every pi radians. All right, those are the two things that you need to remember for tan. All right, now that we have that down, if we have tan x is equal to 1.5, then x is equal to tan inverse 1.5. So that is going to give you an acute angle. This output is positive. So when you take the inverse tan, as I mentioned, as I tried to explain before, you take the inverse tan of a positive value, you're going to get an acute angle less than 90 degrees. So here, the domain restriction is in degrees. So we're going to give our answers in degrees. So that is something you need to remember. All right. So remember, the restriction is in degrees, and our x is between 0 and 360 degrees, or 0 and 2 pi. All right. So we have tan inverse of 1.5. And if you put that in your calculator, you get 56.3 degrees to 1 decimal place. All right. So now because tan repeats, if you remember, tan is positive in the first quadrant because all trig functions are positive in the first quadrant. Tan is negative. Only sine and cosecant are positive in the second quadrant. Add sugar, 2. Tan is positive in the third quadrant, and it's negative in the fourth quadrant. So when you're making this 360 degrees or going 2 pi around, you see that tan is positive in the first and the third quadrant. So you actually have two values for which tan of x is 1.5. So how do you get the other values? Well, because tan has a period of pi, then basically to get the other answer, you need to add pi. And pi is basically 180 degrees. So that is how you're going to get your other angle. So one is 56.3 and your other angle, and this is acute, remember that. So go to 180 is here, and basically adding 56.3 takes it to the third quadrant where tan is positive. So you add 180 and you get 236.3 degrees. So that is your other solution. 56.3 and 236.3 degrees. All right, so your two answers are 56.3 and 236.3 degrees. That is how you do A. Let's look at B. Sine x is equal to 0.4. So the same domain restriction. Remember your domain restriction. Sine x is equal to 0.4. And let's look at the graph of sine x. And we'll look at the graph for which sine inverse is defined. So that is, the domain restriction is from negative 90 to positive 90. Right? So the graph of sine x between negative 90 and positive 90 looks something like this. So if my output is positive, 0.4 is positive, somewhere here, then my angle is positive as well. And I am going to get an acute angle. So that is what I need to remember. So x is going to be sine inverse of 0.4. So sine inverse of 0.4, I'm going to get an acute angle, which is positive, is going to be 23.6 degrees to 1 decimal place. Now, I am going to give you an identity. If you remember, sine x is positive in the first quadrant and in the second quadrant because A, all trig functions are positive, and sugar, sine and cosecant are positive, and it's negative in the other two. So by symmetry, and if you remember your translations, if you remember the transformations to trig functions, sine x is going to be equal to sine pi minus x or sine 180 minus x. So that is going to be true for all x. For all x. All right. And now that we have that down, basically, to get my other angle, if I have x, I'm going to do pi minus x. So my other angle is going to be 180 degree minus 23.6 degrees. So actually, rather than rounding off now, I'm going to do 180 degrees minus 23 the exact value, 5781, yada yada. And my other angle, and basically for 360 degrees, for 0 to 360 degrees, we're going to have two answers. And it's not true. If the domain restriction is different, we have to think a bit more. All right. So 180 minus this angle will give me 156.4 degrees. And if you check, this angle is in the second quadrant. So those are your two answers, 23.6 degrees and 156.4 degrees. So if I have x, the other angle in degrees is 180 minus x. If your x is in radians, it's pi minus x. All right. So we're done with B. C. This was C. All right, so your two angles are 23.6 degrees that you got by taking sine inverse. And to find your other angle, you just had to look for your second quadrant angle. And these are the only two valid angles for 360 degrees. If you're going one more round, we would have more answers. We would have to add 2 pi to both answers, but that's another thing. So if you look at different domain restrictions, for example, here, you only have 0 to 180. For some questions like, maybe on the other page, let's see, for negative, okay, we don't have any negative restrictions until now, but if we get to a negative domain, then we'll also have to think in that way. All right, so 23.6 and 156.4. So if it's from 0 to 360, you get x, you try to get your acute angle, and then for sine, you do 180 minus x. Fairly straightforward. All right, so E, now we're getting to cosine x is a bit tricky. Cosine, so for the other question part, E says cosine x is equal to negative 0.6. All right, so how do we work with this? If you remember the graph of cosine x for which cosine inverse is defined, then the graph looks something like this, right? It's defined from 0 to 180 degrees. So 0 degrees to 180 degrees, right? 180 degrees, where it starts from positive 1 and goes to negative 1. So this is where your cosine inverse is defined. If you restrict your domain like this, then cosine inverse is defined. So if you have a negative output here, your output is negative, which is going to be on the negative y-axis, then your angle, so this 0 point, this 0 is at 90 degrees, right? Your angle, when you take cosine inverse, your angle is going to be between 90 and 180. If your output is negative, your angle is going to be here, between 90 and 180. If your output was positive, your angle was acute. But now, so if you take cosine inverse of negative 0.6 on your calculator, and make sure your calculator is in degrees mode. So negative 0.6, you are going to get an angle in the second quadrant between 90 and 180. So if you do cosine inverse of 0.6, cosine inverse of negative 0.6, you get 126.8698 something. So I'm going to round it to 126.9 degrees. Now for cosine x is going to be cosine 2 pi minus x, or cosine 360 degrees minus x degrees, if x is in degrees. So if angle is in degrees, you use this. If angle is in radians, you use this for all x. And if you want to know why the two formulae that I gave you work, it's because, well, if you think about it in terms of graph transformations, and if you try to visualize it, you'll see why it works. If you do this transformation, then you will realize that your cosine function just becomes the cosine function again, even after applying this transformation. All right, so now knowing this, to get your other angle, cosine, remember, is positive in the first quadrant and in the fourth quadrant. It's negative in the second and the third. So to get your other answer, you just need to do 360 degrees minus 126.9 degrees, right? So it's negative in the second quadrant. So this is in the second quadrant, and your other answer will be in the third quadrant. And to find that, we are going to do 360 minus 126.9. And we get this idea from this symmetry here. All right, the 360 minus 126.9, sorry, I mistyped it in the calculator, but if you do that, you get, okay, so I want to round off after I do subtraction. So use actual values. So 126.869 so that it doesn't affect when you round off. And you get 233.1 degrees to one decimal place. So those are your two answers, 126.9 degrees and 233.1 degree. All right, so that is E. And finally, we're going to do G. So another piece of advice is that always work in terms of sine, cos, and tan, because we know a lot about those functions. We usually don't work with secant, cosecant, and cot. 3 secant x minus 4. 3 secant x minus 4 is equal to 0. All right, so this is just 3 over cos x, because secant x is 1 over cos x, is equal to 4. Now let me multiply both sides by cos x. And cos x is equal to 3 over 4. And 3 over 4 is just 0.75. All right, and if you remember, if I had a negative output, my angle was in the second quadrant between 90 and 180 degrees. If my output is positive, my angle is going to be in the first quadrant between 0 and 90 degrees. And this is only true for cosine. So x, if you do cosine inverse of 0.75, you're going to get a first quadrant angle. Cosine inverse 0.75 in degrees is 41.4 degrees to one decimal place. Now, how do you get the other angle? Fairly simple. The other angle is just 360 degrees minus 41.4. And why 360 minus 41.4 is because of the symmetry that we discussed previously. And your other angle, which has to be in the fourth quadrant. Remember, cosine is positive in the first and the fourth quadrant. So it's positive here. So the other angle has to be in the fourth quadrant. And 360 minus this will give you the answer. And that is 318.59, which is 6 degrees. So this and this are your two solutions, 41.4 and 318.6 degrees. All right. So that is how you do. And this only works for this restriction. For other restrictions, we'll have to think in other ways. But for question 2, the restriction is the same. We're just working with radians now. 0 to 2 pi just means 0 to 360. So everything we've discussed still applies. All right. So we have sine of x equal to 0.3. And now I need to change my calculator to radian mode. And that is it. And now I have sine of x is 0.3, right? So x, and if I do sine inverse of 0.3, I am going to get an acute angle in the first quadrant, right? So I get 0.30 again to 1 decimal place, and I'm working with radians. Now, how do I get my other angle? The other angle that works, that gives me 0.3, is just going to be, if you remember, sine of x is equal to sine of pi minus x in radians. So I just need to do pi minus 0.304692654. That is what the exact answer that you get when you take sine inverse. And your other answer is just going to be 2.8 radians. And that is it. To 1 decimal place. We're always going to round off to 1 decimal place for trigonometric equations. And yeah, I think the textbook rounded off to, if it's degrees, they have rounded off to 1 decimal place, but if it's radians, they have rounded off to 3 significant figures. All right, so for degrees, so I'm following the textbook, they did to 1 decimal place. For radians, they did 3 sig figs. All right, so I'm going to follow that from now. So if I have to round everything off to 3 significant figures, 0.305 radians is going to be your answer here, and 2.8. So the textbook is not consistent. I'm not sure why. Maybe it's because there is a convention that I'm not aware of as of now, but we're going to follow the textbook. And yeah, so these are your 2 solutions to 3 significant figures for radians. So 2.84 and 0.305. And because we're only working from 0 to 2 pi, for this domain restriction, your answer, you only have 2 solutions. For sine of x is equal to some value, only have 2 solutions. All right, so we're done with B. And D is very similar. D says, okay, we're going to work with sine, cos, and tan, so it's all right. It says sine of x is equal to negative 0.7. Now, this is interesting because if you remember, if you restrict the domain so that sine inverse is valid, it's this. So if your output is negative, which negative is here, then your angle is actually also going to be negative. So that is what you need to remember. Your angle, when you do the sine inverse, is going to be negative. And remember, because your restriction is from 0 to 2 pi, your angles cannot be negative. So we're going to have to work with that somehow. So first of all, let's just take sine inverse of negative 0.7. Right? And yeah, so if you do sine inverse of negative 0.7, then you have negative 0.775. That is 3 significant figures. All right. So here's, you know that sine is an odd function. Sine of negative x is just negative sine of x. And using this information, sine of negative x, right, is equal to negative sine of x. So sine, if I'm saying that sine of negative 0.775 is equal to negative 0.7, then I can also say, because again, I'm solving for x. X goes here, right? So I can actually take this negative out. So sine of 0.775, because using this formula, is equal to negative 0.7, and this 0 cancels out. So I have sine, I know that sine of 0.775 is equal to 0.7. All right. I cannot use this answer. This is going to be helpful, but I cannot use it. Now let's look at our quadrants. Sine is positive in the first quadrant and in the second quadrant. So my solutions actually have to be in the third and the fourth quadrant, right? So now let's look for my third and fourth quadrant solutions. So if I have an acute angle, which I do, this is acute, then my solutions for sine for 0 to 2 pi are going to be 180 pi minus acute angle, so 0.775. And I encourage you to use the full value. So my solutions are going to be pi, so pi plus the acute angle will take me to the third quadrant. And again, angles are measured anti-clockwise. So in this direction, so pi plus and 2 pi minus. So that is how I'm going to get to my third and the fourth quadrant using acute angles. This only works if you have acute angles. And if you notice, 0.775 is going to be acute. So your solutions that satisfy are going to be pi plus your acute angle. So 0.775, da 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 da. So if sine of this positive gives me 0.5, pi sine of this is just going to be sine of 0.775. If I have pi, 2 pi, then I know this works. And this is in the third quadrant, so it's negative. So I know that this gives me negative 0.7, right? From here. So I know that the angle pi plus 0.775 is going to work. And 2 pi minus 0.775 is also going to work. All right. So I encourage you to use full values. So pi plus, okay, so sine, okay, so I encourage you to use whole values. So your pi plus this angle gives me 3.92 radians. That is one solution in the third quadrant. And the fourth quadrant solution is going to be 2 pi minus the whole expression. So 0.7753974,966. And it's going to be 5.51 radians, 3 significant figures. So I hope this made sense. If your angle is negative, you want to go and look at your domain restriction. And your domain said you can't have anything less than 0. So then you just figure out what your acute angle is. And in this case, using symmetry, using the fact that sine is an odd function and everything, you know that sine of 0.775 is 0.7. And then you just need to take that to the third quadrant and the fourth quadrant by subtracting and adding it to pi and 2 pi respectively, right? So that is how you get 3.92 and 5.92 and 5.51 radians. So these are your solutions. All right. So it's a bit trickier when you work with negative values, but I hope this made sense. All right. And again, only works if you have 0 to 2 pi. For other restrictions, we need to think in other ways. Cos x is negative 0.5. Cos x is negative 0.5. And we know when cos is... So if you just do x is equal to cosine inverse of... So this is something that we can actually get an exact value of, if you remember. Now, x is going to be cosine inverse of negative 0.5. Now, if you remember, cosine... Now, if you remember, cosine of pi by 3, which is pi by 3 radians, is 0.5. Cosine 2 pi minus pi by 3, remember, pi by 3 is acute, right? So I need to, sorry, not 2 pi minus pi by 3, but cosine. So cosine is negative. Cosine is negative in the second and the third quadrant. So if I know my acute angle that gives me 0.5, pi by 3 gives me 0.5, then this is acute. It's because pi by 3 is 60 degrees. 60 degrees is acute. Then I just need to take this acute angle to my second quadrant and my third quadrant, and cosine is negative here. So how do I get to my second quadrant using this acute angle? Well, 180 minus an acute angle is going to be in the second quadrant, and 180 plus an acute angle is going to be in the third quadrant. So my two solutions are just going to be pi minus pi by 3 and pi plus pi by 3. So those are the two angles that are going to give me negative 0.5. So pi minus pi by 3, that is going to be 2 pi by 3. This is going to be 4 pi by 3. All right. And yeah, these are your two angles, and you can just plug it back into your calculator to check. So always recheck your answers. So if you know acute angles, then if you know the acute angle, then it's just a matter of subtracting from pi, or just basically using pi and 2 pi to send them to their quadrants where they are negative. So cosine is negative in the second and the third quadrant. So pi minus an acute angle is going to be in the second quadrant, and a pi plus an acute angle is going to be in the third quadrant, where cosine is negative. So you get 2 pi by 3 and 4 pi by 3. All right. So yeah, we're done. And we have 2 cot x plus 5 equals to 0. So 2 cot x plus 5 equals to 0. So to solve this, we can write it as 2 over tan x is equal to negative 5. 2, so I sent 5 to the other side and I wrote cot x as 1 over tan x is equal to negative 5 tan x. And therefore tan x is equal to negative 2 over 5. All right. And now x is just tan inverse negative 2.5. But we are going to get a negative angle again. So if you do this, you are going to get negative 0.381 radians. 805, I'm going to keep the whole value on my calculator. 05063771 radians. But if you remember, tan of negative x is equal to negative tan of x. Tan is also an odd function. So basically, tan of, and I'll leave you to figure out the logic of this, but tan of 0.3805 ... this expression is going to give me positive 2 over 5. And now I know the acute angle. Tan is negative in the second quadrant and in the fourth quadrant. So now how do I send tan to the second quadrant? Well, pi minus an acute angle, this is acute, we'll send it to the second quadrant, and 2 pi minus an acute angle, we'll send it to the fourth quadrant where tan is negative. So we just need to do that. So pi minus, so we just need to figure out the positive first quadrant acute angle. And if we can do that, then it's just a matter of taking the angles into the respective quadrants. And usually we try to avoid working with negative angles like this. We just want to use symmetry. So pi minus this gives me 2.76 radians, and 2 pi minus the acute angle gives me 5.90 radians. And yeah, those are your two solutions. So I don't want to write 903, but because that would be to 4 significant figures, so I'm just going to leave it at 5.90 radians. And we are done. So if it's with negative values, usually we want to try to figure out the acute value in the first quadrant, and then we will use that acute value to send the angle into the quadrant where it's negative or positive. So we just want to think in terms of that. And I hope this explanation was clear. All right, so we're just abusing symmetry at this point. All right. So now, remember, instead of working with x, we are working with 2x. All right. So now we are working with a different angle restriction. So 3a, we have cosine of 2x is equal to 0.6. Now, we got comfortable working with x, working with one variable, like not working with a variable just like x or just u. So I will write down the domain restriction. And since we're working with 2x, let's see what happens to this inequality for 2x. So I just multiplied x by positive 2, so I need to do that to both sides. And let me rename 2x as u. And you will realize that, hey, u is just between 0 and 360 degrees. And that is the question that we worked in question 1. So we can use everything we use for question 1 now. But we just need to remember to substitute things back. So cosine of something is positive. So if you take the cosine inverse, then you get your acute angle that is in the first quadrant. All right. So if you do this, you get 0. And we're working with degrees now. So I want to switch my calculator back to degree mode. All right. So cosine inverse of 0.6, we get 53.1 to 1 decimal place, 53.1 degrees. And how do you get your other angle? Well, it's just going to be 360 degrees minus, if you remember, 360 minus x. So 53.1 degrees. Right? I'm 13010 dot 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 degrees. And that is going to be 360 minus this. If you do it, you get 306.86 is going to be rounded off to. Okay, I'm just going to keep the values because I also need to do one more operation. 010235 degrees and 8698976 degrees. All right. But remember, u is 2x. So one thing I need to worry about is, do my two angles satisfy the inequality for u? U is between 0 and 360. So it's between 0 and 360 for sine, cosine, I only have two solutions. And tan, I only have two solutions, right? So this is one solution, this is another solution. So if it works for u, it's going to work for x. So this is just 2x. So this implies that x is this ugly 53.1 expression divided by 2. That is 26.56, which is 6 degrees. And this implies that x is 306 point this. Okay, sorry, I pressed the graph option in my calculator and now it's just stuck trying to plot a graph that I don't think exists. All right. So for the other expression, it's going to be 306.86 something divided by 2. That gives me 153.4 degrees. So those are going to be my two solutions. 26.6 and 153.4 degrees. All right, so we're done with A. So these are your solutions. So we worked with U, and then finally we gave our answers back in terms of A. So that is going to be the general way to approach these. So sine of 3x is equal to 0.8, right? X is between 0 and 180 degrees, given. So let's look at the inequality for 3x. It's going to be, I believe, something like this, 540, I think. 180 times 3 is 540 degrees. All right, and now we're going to rename 3x to be u. All right, so sine of u is equal to 0.8. And remember, 540 is like 360 plus 180. So we need to check for one round, which is 360 degrees, and we need to check for one more round. So that is the idea. We need to check for one round, and we need to check for one more round. Half a round. So we need to check for one round, and then half a round more. So that is something you need to keep in mind. So sine of u is 0.8. U is just going to be sine inverse of 0.8. And sine inverse of 0.8 is going to be an acute angle, which is 53.13010235 degrees. So that is the acute angle solution. And if you have your acute angle solution, we know that another solution that is going to work is you subtract it from 180. 010235. All right. So these are going to be your two solutions from 0 to 360. So we know our two solutions from 0 to 360. So how do we get more solutions? So we know that sine is positive in the first and the second quadrant, right? So we have our solutions. We have our first quadrant and second quadrant solution for one round. So how do we get the solutions for my second half round? Because my second half round, which is this, passes through both the first quadrant and second quadrant. So I'm going to have two more answers there. So how do I get that? Well, I just take my first quadrant answers. If I take my first quadrant angle, I add 360 to it. It's going to loop back to my first quadrant. So 360 plus an acute angle is going to be back in the first quadrant. And 360 plus an angle in the second quadrant is going to come back to the second quadrant. So that is something I need to remember. So I'll get my answers here, and then I'll add 360. All right. So my two answers are 126.869897 degrees. And now, I also can add 360 as discussed to these answers. So if I do that, I get 413.1301024 degrees. And I'm going to tell you why I'm writing whole values in a minute. So if I add 360 to this, then I get 486.8698977. All right, so I have my 4 solutions for u, because I was working with u, right? And u went to 540 degrees, which is 360 degrees plus 180 degrees. All right. And now that I have my 4 solutions, remember, u is just 3x. And the question did not ask me about u, it asked me for 3x. So x from this, I know, is going to be 17.7 to 1 decimal place degrees. From this, x is going to be 42.3 degrees. From this, x is going to be 137.7 degrees. And from this, x is going to be, if you divide by 3, 162.3 degrees. So these are your 4 solutions: 17.7, 42.3, 137.7, and 162.3 degrees. All right. So you have 4 solutions, and we saw these 4 solutions by thinking about the quadrants and going around. We're doing rotations. All right. Okay, so a bit tiring. So we have E. E says 2 secant 2x is equal to 3. Again, remember your domain restriction. So we are working with 2x. So let's look at 2x. 2x is just going to be between 0 and 360. And we'll just call this u for now. So this is something we're used to, going from 0 to 360. So this is going to be a quicker question. So secant 2x is 1 over cos 2x, and we just said 2x is u. So I'm going to get this expression. And if you simplify, you get cos u is equal to 2 over 3. And u is cosine inverse of 2 over 3. So you get an acute angle between 0 and 90. And the reason why we get this has already been discussed. So you get 48.1896851 degrees. All right, so that is 1. Right? Now, how do we get the other for cosine? Well, the other angle is just going to be u is equal to 360 minus this angle. All right. And that is going to be 311.8103149. And all right. So we have our 2 answers. But remember, u is just 2x. So 2x is equal to 48.1896851. So this implies, so we can get our values of x from here. And again, if your answers satisfy for 360, then it's going to satisfy for x. Don't worry. If your inequality is consistent, if it's working for u, then when you divide, it's going to work out for x. So basically, your first solution is going to be 48.18 divided by 2. You get 24.1 degrees to 1 decimal place. And then your other solution is going to be 311.81 divided by 2. That's going to be 155.9 degrees. So those are your 2 solutions. 24.1 degrees and 155.9 degrees. All right. So we're done with E. And finally, we have G. So for G, you have 4 minus 2 tan 2x. Again, we're going to use, if x is between 0 and 180, then 2x is between 0 and 360. And then I'm going to say 2x is equal to u. All right, so 4 minus 2 tan x is equal to 0. So basically, 2 tan u, I send this to the other side, is going to be equal to 4. And tan u is just 2, right? All right, so u is going to be tan inverse of 2, which gives us an acute angle in the first quadrant. And that is just u is 2x, which is a 63.4349,482 degrees. And again, because the period of tan is just pi, to get your other angle, you take your value, 63.43, and remember, we were working with u, so we use u throughout. 43.494882 degrees plus pi. Pi is just 180 degrees. So 180 plus an acute angle will take you to the third quadrant where tan is positive. So 2x, which is u, is going to be 243.4349488 degrees. So therefore, x from this is going to be 31.7 degrees, and x from this to one decimal place, if you divide by 2, is going to be 121.7 degrees. So 31.7 and 121.7 are the two solutions. All right, and we're done. So now we're going to look at more complicated problems. So we're going to do B first. B, D, E, and F. All right. So B says that cos 2x plus 45 degrees, we're working with degrees, is equal to 0.8, and 0x is between 0 and 180. Well, we don't have x here. We have 2x plus 45. So let's try to create 2x plus 45 in this inequality. So if I multiply by 2x, as I have done, I get this. And now I just need to add 45. So if I add 45 to this inequality, then 360 plus 45 is 405. And I'm going to call this u. So we're working with u, which is between 45 and 405. So cosine of u is 0.8. So let me take cosine inverse. It's going to give me an acute angle, right? It's going to give me an acute angle between 0 and 90. And the reason why it does this, I have already told you. So this is 36.869897 degrees. But this, we're working with u, and u is at least bigger than 45, is equal to or bigger than 45. So this answer is not valid. This is an invalid answer. But remember, the nice thing about acute angles is we can use acute angles and symmetry to figure out the correct answers. So this does not work. Well, cosine, when else is cosine positive? Well, cosine is positive in the first quadrant. Cosine u was positive. So cosine is positive in the first quadrant. It's positive in the fourth quadrant. All right, so we need to go to the fourth quadrant. And if you know your acute angle, we know that cosine, the other angle, 360 minus this acute angle, should also give you an angle in the fourth quadrant that works. All right, so if you do 360 minus that angle, you get 323.13 degrees. 323.1 degrees. Sorry, let me write the whole expression. 1301024 degrees. All right, and does this satisfy the inequality? Yes, it does. So this is one value for u. So this is valid because this is in the fourth quadrant and we got it using the acute angle. So even though the acute angle itself is an invalid response, we can use it to figure out the valid answers. So one is in the fourth quadrant. And remember, 405 is just 360 plus 45. So we can go one round and we can still go 45 degrees more, right? So let's add 2 pi to this answer. So other valid answer in the first quadrant, so our initial first quadrant answer did not work, but we can go a bit more, right? There is still a possibility that we can go a bit more because we're not restricted to just 360. We can go 45 degrees more. So let's add 2 pi to our first quadrant answer. So 360 degrees, which is 2 pi, plus our first quadrant answer, which is this, 36.869897 degrees. dot 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 degrees. So my other answer is 360 plus that acute angle, which is 396.8698977 degrees. All right. So now, does this satisfy the inequality? Yes, it does, because it's less than 405. And if you check any more answers, you're going to see that nothing else works. Because your next answer that's valid will have to be in the fourth quadrant. So it has to be this plus 360, which is going to exceed 405. All right. So now that we have this, this is u is just, remember what is u is. U is 2x plus 45. And this is valid as well. So basically, now if you use this expression to calculate x, and I'm not going to do the calculation, I'm just going to give you the final answer. But if you use it to calculate x, so 323.13 minus 45 divided by 2, your first solution for x is 139.1 degrees. And your second solution for x, you take 396.86, whatever, this expression, you subtract 45 from both sides and you divide by 2 because you have 2x here. And you get 175.9 degrees. So these are your solutions. 179, I don't even remember which question we were checking. Okay, it's 4B, right? Okay, 4B. So it's 139.1 and 175.9 degrees. And okay, the textbook gives answers in radians. And I think initially there was a different question because these have to be your answers. And you can always plug these values in. If you do cosine, you plug it into your calculator. You change your calculator to degree modes, 1392 times 139.1. So you plug your x values here. Plus 45. Your answers have to be very close to 0.8. So if you plug this, you get 0.8007. So which is correct to like 2 decimal places. So it works. This is valid. To 1 decimal place is valid. And if you plug this in, cosine 2 times 175.9 plus 45, you also get the same expression. So these are your solutions. The textbook has wrong back answers for this. All right. Quite hectic. I know. Part D, you have 3 sine 2x minus 4 is equal to 2. And we're working for between 0 and pi. But I want to look at the inequality for another value, right? For 2x minus 4. So if I multiply this inequality by 2, I get this. And now I just need to subtract 4. So 0 minus 4 is negative 4, 2x minus 4, and then 2 pi minus 4. So negative 4, I'm going to call this variable u, and 2 pi minus 4 is approximately 2.2831, yada yada. So this bound is going to be useful. And I just renamed this variable to be u. So sine of u is equal to 2 over 3. All right. So remember, our u can be negative. Our u can be negative. All right. So let's try to get our acute. Okay. 2 pi minus 4. So this was about 2.283185. Okay, let's remember this bound. I don't know why it's disappearing. Okay, let's remember this bound. So now u is sine inverse of 2 over 3. And you need to change your calculator to radian mode because the question is in radians. So sine inverse of 2 over 3 is 0.7297276562 radians. And this satisfies the inequality, so there's nothing to worry about. And another value that we have discussed would satisfy the inequality, that would give us the value, is pi minus your acute angle, right? So let's try pi minus this value. And if you do pi minus this value, 0.7297 ... you're going to get 2.4. radian. And 2.4 exceeds this. So this is invalid. So our second quadrant answer is actually not valid. So we need to think about, now we have already checked, right? We took our first quadrant answer, which is this. We tried to check for our second quadrant answer, but it was too high. It went above 2.28. So we don't need our second quadrant answer. But remember, our angle goes up to -4 radians. So -4. So if you remember, negative angles, right? You start, this is your reference. This is your reference. Negative angles are measured clockwise. This is negative pi, and negative pi is 3.14 radians approximately. -4 means that we can go up to our second quadrant in the negative direction, right? So if we can go up to our second quadrant, then we are still gonna have a valid answer. So our next valid answer is gonna be a negative angle. So how do we figure out? Well, like I said, we are going from negative pi, and we have to check for the acute angle, right? We're always using our acute angles to transfer into another quadrant. So let's check negative pi minus 0.7297276.562. Negative pi minus this angle gives me negative 3.87, right? Negative 3.87132031. And this is valid. This is greater than -4, so it's valid. Now let's see if we can also go to our first quadrant. How do we do that? Well, we have our first quadrant. If I subtract 2 pi, we're gonna loop back into our first quadrant, right? If adding 2 pi loops into the first quadrant, subtracting 2 pi for negative angles is also gonna loop back. So 0.72, if you take your angle, right? So if you take this angle and you subtract 2 pi so that it loops back for a negative angle in the first quadrant, you will get -5.5355. So that is 2 less than -4. So that's not going to work. So you only have 2 valid answers. U is this in the first quadrant, and U is this in the second quadrant from the negative direction that satisfies this inequality. All right. So U is just 2x minus 4. So U is just 2x minus 4, and if you solve for x using this expression, you are going to get, you add 4 and you divide by 2, you are going to get x is equal to 2.36 radians. That is one solution to 3 significant figures. And 2x minus 4, if you solve for -371 ... If you solve for this, you add 4 and you divide by 2, you get x is equal to 0.0643 radians. Yes, and those are your 2 solutions. 2.36 radians. And so, yeah, the textbook doesn't do things consistently. I don't know why. So, yeah, 0.0643, the textbook has rounded it off to 0.06, and 2.36 has been rounded off to 2.4. But it's the same. All right, so we're done with D. Let's do E. All right, so we have 2 tan x over 2 plus root 3 is equal to 0. For 0 degrees, x 540 degrees. So we are working with x divided by 2 now. So 0 divided by 2 is 0. For x by 2, 540 divided by 2 is 270. So we're only working between 0 and 270 degrees. And let's rename x over 2 as u. All right, so I'm going to call this as 2 tan u is equal to, take root 3 on the other side, I get negative root 3. And I get tan u is negative root 3 over 2. So u is tan inverse. And because this is negative, I am going to get a negative angle. And I don't need a negative angle, but we'll have to work with that. So tan inverse of negative root 3 over 2 is, and I need to do this in degrees. So I need to change my calculator to degree mode. And yeah, okay, tan inverse negative root 3 by 2 is negative 40.8933 degrees. But this tells me that tan of positive of this acute angle, and I love acute angles, right? Acute angles make our lives. It's going to be the positive root 3 by 2. So tan, the positive acute angle is going to give me the positive answer. All right. And this comes from, as we discussed, that the fact that tan is an odd function. So let me just quickly tell you why. If tan, negative 40.8933 degrees is giving me root 3 by 2, but tan is an odd function. So tan of negative x is negative tan of x. And if I cancel negative signs on both sides, I know that tan of this angle is root 3 by 2. Now, if I have an acute angle, I can figure out my answers in any quadrant. For tan is negative, if you remember, in the second quadrant. So I do, and to get my second quadrant answer, I will do 180 minus 40.8933 degrees. That is my second quadrant answer. And tan is negative in the fourth quadrant, right? So in the fourth quadrant, my other answer would be, in the fourth quadrant, I need to do 360 minus the acute angle. All right. So if I do 360 minus the acute angle, I get 319. And if you check your inequality, tan u is limited to growing up until only 270. So this is invalid. This is invalid. So you only have one valid answer for this question, actually. And that is 180, the angle in the second quadrant. So u only has one value, which is 139.1066054 degrees. And now u was just x by 2. So this implies that x is just 2 times this expression, right? Because u is x by 2. So if you multiply by 2, you get 278.2 degrees. And that is the only answer that is valid. 278.8 degrees. Sorry, 278.2 degrees. You only have one answer for E. And for this video, the final question is going to be F. All right. And again, if you look at your restrictions, it's from 0 to 4 pi. So you have root 2 sine x divided by 3 plus pi over 4 is equal to 1. So 0x 4 pi, right? All right. So we have x divided by 3 here. So let's just divide by 3 everywhere. So I get this, right, for this inequality. And because I'm dividing by a positive value, I don't need to worry about the direction of the inequality. And I need to add pi by 4. And 4 over 3 plus pi by 4, right? And you need, if you simplify this as a fraction, this is going to be 16 pi. 4 times 4 pi is 16 pi. 3 times, you have 3 pi. 3 times pi is 3 pi. 3 times 4 is 12. So this is going to be 19 pi by 12. So your answer, if I call this angle, the angle that I'm working with, as u, right, then u is between pi over 4 and 19 pi over 12. So that is something you need to remember. All right. So sine of u is equal to 1 by root 2, right? So now, 1 by root 2, well, that's something I'm very familiar with. And I know that sine pi by 4. So the first solution is u is equal to pi by 4, right? Pi by 4 gives me, 45 degrees gives me 1 by root 2. But remember, u is bigger than pi by 4. So this is invalid. So this is my first quadrant solution. How do I get my other solution? Well, it's 180 or pi minus pi by 4, right? Another solution is in the second quadrant, pi minus pi by 4, using symmetry of sign, and that gives me 3 pi by 4. And this is one valid solution. Now let's think of other solutions. Well, up until 360 degrees, which is 2 pi, right? So let's write this in terms of, let's write this in terms of pi. All right. So 19 pi I can write as 12 pi plus 7 pi, right? And I can distribute this. I can write this as 12 pi over 12 plus 7 pi over 12, and 12 pi over 12 is just pi. So, and if you think about it, 7 pi divided by 12, this is just 1.8. And basically, this is 180 degrees. 7 pi over 12, I think, is acute angle, right? Pi over 12. Pi over 12 is 15. 7 times 15, okay, it's 105. So it goes up to the fourth quadrant, right? So in degrees, this is 180. Pi over 12 is 30 degrees. And then basically, pi over 12 is 15 degrees. And 7 times 15 is 105. So if you add them together, you are going up to, so the maximum in degrees, so your U is between 45 degrees and 180 plus 105 is 285 degrees. All right. And now sine is positive, right? Sine of U is positive. And sine is only positive in the first and the second quadrant. So up until 285, if you know, 285 is somewhere in the fourth quadrant here. The only two valid solutions you'll find are in the first and the second quadrant. If you add 360, it's going to exceed 205. So your only valid solution is actually 3 pi over 4. So what is U? U is x over 3 plus pi over 4. 3 pi over 4. Only valid solution. So x over 3, if you subtract pi over 4 on both sides, you get 2 pi over 4, which is just pi over 2. And therefore, x you are going to get is 3 pi over 2. That is the only valid solution. 3 pi over 2 for f. And that is it for this video. And we're going to solve more trigonometric equations in the next two videos, I think. All right.